My name's Ethan Tummins. I'm part of the blue team. My teammates are Jeffrey Cloudis and Jerry Bassam. And we're in the spray booth pressure system, and we're looking at the steady state and step response. Okay, this was the design of our pressure booth system. As you can see, we have the blower here, goes through booth 1, 2, and 3. You have dampers or valves, either or. You can close off and close each one, booth 2 or 3 or both. For our system, we had our damper 2 closed, so our booth 3 was not getting any pressure. As they go through the booths, they go through a filter system which is regulated for EPA agreements throughout Tennessee and other areas. The theory is to find the steady state operating curve, or the SSOC. And for the step response is to find the K value, which is gain, the T0, which is dead time, and tau for the time constant. As you can see, we have the simple system here. You have put an input value through the the Chem Lab website. You give a percent of power, and then it goes through the system downstairs on the first floor, and it gives you an output booth pressure. This is our steady state operating curve for one of our values ran. This input value is 45% power. You can see it takes about 1 second for the pressure to reach steady state. And then this circle, blue circle right here, it reaches steady state throughout here. The steady state is about 13 centimeters of water. Our group had, this one is for the 5 through 13 centimeters of water, and our group had different sections to get different output values of centimeters of water. As you can see, it was done multiple times with different fixed input values. This is just an example of one of them. Then this is when we all ran our experiments. We got all of our different input values, took the average of them, and it gave us this curve right here. And you can see pressure equals 0.7 times the input value. This is the average of all the plots ran. This is our groups. Now we go to the step response results. For here you put in an input value, and then you put in a step response increase value. This is the pulse, so it's going to go at a certain operating power, then increase a certain power, and then decrease back to that same power. So we have the input value of 20% with a gain of 20% input value. And through calculations, you can find your gain is 0.5 centimeters of water per percent. This is for the gain. The next one is for the T0. You can see this is the coming down section for the dead time. You have your input value decreases back to what it was, and this is your pressure system. You take lines, graph out this point, and take the difference in time from when it starts to decrease to your tau naught, which is about 0.1 seconds. It wasn't very much at all for our system. And this is for the time constant, for tau. You took 0.63% or 63.2% of your gain. Come here. You find the difference in here, which was about 0.2 seconds. Again, not very much for us, for the spray booth pressure system. And for our conclusions, this is just our overall of one of the going ups overall. Our gain for the average of 3 systems ran was about 0.5 centimeters of H2O per percent with error bars, kind of a little hard to see, but. And the conclusions for the steady state was it just took about 1 second for it to reach steady state. So unlike temperature, the pressure system, just once you put the input value, it automatically goes straight up to the pressure that you're desired to have. That's why our graphs look pretty good for the pressure system. And then the dead time with its error bars, which is about 0.1, and then tau is about 0.2. Again, just T0 and tau is not very much. And this is the end. Any questions?